all of you smiling, glad to be back.
Hey, good to see you. Okay,
Really? Somehow I'm not necessarily buying that, sir. Where is the...
Nope, just power. Yeah.
Well, if they had it up there, how much was
Yeah, it took me forever to find it too. Should be yep,
All
there.
right, all right, thank you. Oh, phones, I love to hear the phones. So in the future, anytime the phone rings, I get it. So you answer it, and then I get to talk to whoever called you. It's really nice. I've talked to a lot of really cool people. So
So you're saying we should all call each other?
you can.
If you have a question.
Matter of fact, and one person I like actually, they people. It's really cool. People actually hand you their phone, and so I got to talk to the mom, and like every couple of months we would like call her up. How you doing? Your daughter is doing wonderfully in class, because she always wants to know. She's studying hard. Oh yes, absolutely. Okay, so you really came back even though you had these problems dealing with me in the spring? Yeah.
No, I had a class in summer.
Well, yeah, in the spring part of the
Yeah.
summer. Tell them how easy it was.
It's fairly easy, yeah.
Isn't that a ringing endorsement of this? All right. So next week we will be next door. So because we're so crowded in here, there's more room next door. It's actually open. So because they're recording, they had it all set up for in here. We'll be in here tonight, but next week we'll be next door. So if you want to wait in here for us, come and wait, but don't expect us to show up. All right, as you guys have all done for the distance learning, the University of Michigan Dearborn College of Engineering and Computer Science records courses held in this classroom. Both audio and video are recorded, so smile nicely for the camera. Recorded information will be used for educational purposes only. Continued enrollment in this course acknowledges your understanding of this information. So that's really great. All right, so you're here for the database class. Is that true? So I'm in the right class, so that's a good thing. In my other class this semester, I had people show up for an astronomy class, and it's like, I don't think that's quite what we are going to be talking about, but it's okay. All right, so databases. You're all excited about databases. It's a really exciting class, and we're going to work you a lot. It's great. All right, so database systems, 3 credit hours. My name is Tom Steiner. If you have not had me before, if you had me before, welcome back. You are in my office, so this is a really nice office. I'm going to change offices next week to the room next door. It's really great. I do have actually 2 offices here on campus that I get to share with like 8 other people, and it's really crowded and nobody shows up to see me anyway, so I just have it in classroom. So I do have a class right before this that ends at 4:45, so if you do have any questions between 4:45 and 6 o'clock, I am here on campus with nothing to do but wait for somebody to come by and say hi to me. So feel free to, if you do have any questions, anything that you want to talk about, there is that time. And there's any time after class. I am here on Monday, Wednesday, and Thursday for classes as well. So feel free to stop by after any of my other classes, and I will be more than happy to chat with you all that you want. Phone number is a really great phone number. You can call and leave a message. I never answer the phone, but if you want to call and leave a message, feel free. Email is the best way to get a hold of me. I check the school email at least once a day, and I attempt to do that on the weekends as well, and it is typically more than that, but you have to help me help you. So I literally get hundreds of emails a day. So I scan the subject line for class numbers. So in this case, you would start it with CIS 556, and that will tell me I need to open this immediately, if not sooner, because you need an answer. I've had people come up and go, you never answered my email, and then say, let's go back and look. And 2 or 3 weeks before, they had sent an email and just said subject line of something, and it didn't have the course number. I go, I don't look at that. I look for the course number. That is the sign of a student email that I need to respond to. So help me help you that by starting the subject line with that, and I will get back as quickly as I can. Okay. I just had office hours, after class, by appointment, before this class. Just send me an email. We'll set up a time, right? Whatever you want, right? I am here to help you, right? And if I didn't know the stuff, I wouldn't be up here. So let's get some things out of this. Right? You're obviously will be in the room next door, as we said, right? So from a course perspective, we're really going to be talking about lots of different database approaches. So the assumption I am making is most of you have not had any kind of database background at all. So if you have, it's gonna be great. You're gonna have to help me out because you guys have lots of experience, right? So that will help with my experience as well, right? But databases are very common, and we have databases all over the place in lots of different formats in different ways. So the approaches that I will be talking about are obviously the ones that I use, but that doesn't mean they are the only ones or they are the best, right? So there's been a number of times in the various courses that I have taught that I learned a new way to do something because of the way that people are doing things differently than me. So I am looking forward to learning from you, hopefully as much as you are looking to learn something from me. Okay? So we'll be talking about database approach to data management, so database fundamentals, relational network hierarchy, database models, normalization of data, distributed databases, things like that. Okay? And if we look at the way that databases typically are out there today, we typically talk about relational type of databases. And that's because that's the norm, but that is not always the best. So I will be describing, for example, some projects that I have been on where we have taken a hierarchy type database and converted it, because that's what the company wanted to do to standardize things, and it actually was detrimental, and we reverted back to the hierarchy one because it was better. And they did that because they didn't understand really the implications of doing things like that. So those are the kinds of things that we are going to ultimately be talking about. All right, so program goals: get a job, be employed, right? Have lots of education from what we do out of this, right? Okay, and be able to apply this in a real world environment. So from a course perspective, understand foundations of database systems, how to manage things, what is the best way approach to databases themselves, conceptual databases versus real databases, developing logical data modeling, apply normalization techniques. So we have normalization, and what they don't say on here is we also denormalize. So there's different processes and reasons that we do that, so we'll be talking about that. Database integrity, security, right? And how do we get to the physical database from a logical? Because actually there is a lot of companies that separate jobs by doing logical database work versus physical database work. I was fortunate enough to do both. Okay. We'll talk about database performance, query, transaction processing, and we'll be talking about things like SQL. All right, the text. So I let the bookstore know that this was out there. I went out there today and looked, and of course it's not even listed for the course. So of course none of you have a book, right? But the really good news about this book is that if you search using that author and that title, it actually comes up and you have a downloadable PDF of the book. So download it and you have it, and you don't have to even pay anything for it. How good is that? How many courses do you get that from, huh? Right? All right. So these reference books, right, are just listed there because those are some of the ones that we have used either in the past. So some of the other instructors use different books when they teach this particular course. Or these are ones that I have used in the past as well, compared to the one that we are using. Okay, what you guys are all interested in is what is your grade going to be based off of, because we know that you really are concerned about your grades. Okay, all right, so a midterm and a final, right? So 30% each. You'll have some written assignments that you will be doing, that is 20%, and you'll be doing a project, and the project can either be individual or a group project. You will get a choice in how you want to approach this. Okay. So late work, 5% each day, up to 3 days. Partial days count as full days. When we talk about that. So if it's due at midnight and you turn it in at 1 a.m. the following day, sorry, but it's a whole day late. So 5% off. So plan accordingly. Okay? Cheating, don't cheat. We hate cheating. It's a big pain to have to go through and do all the things related to that. I had an instance of that recently where I had to take the people that cheated, and my offer to them was to reduce their letter grade in the course by 1 letter grade. And they thought that was unfair, so we took it to the department and they thought it was unfair as well. So they failed them completely in the course rather than just a 1 letter grade reduction. So, right, it's taken very seriously. You guys are all really smart and capable and professional, so I don't expect any kind of issue related to that. Okay, if you look at the grading scale, what kind of scale is that? Straight scale. I haven't had to go off of a straight scale in probably about 20 years. So the likelihood that will happen in this class is probably close to 0. So know where you're at, plan for it, right? Again, right, what we're going to be talking about here and what you're going to be doing is all doable, right? This is all stuff that I've had people do before in this class and they have been successful at it. So if they can do it, I know you can do it. Okay. All right, and no rounding up. So, all right. So I have a list of specific topics here. So you notice I don't have dates, right? And the reason I don't have dates is because I prefer not to be tied to specific dates and, oh, I'm behind by a week or I'm ahead by a week, right? That's not the purpose of what we're trying to do here. This is the list of topics that we are going to try to get through all of them, but since kind of they all build on each other, if you don't understand one, I'm not going to race through to get to the next one just to hit a schedule, right? We need you to be at the end of this course, walk out of here with a complete understanding of all the material that we have covered up to that point. And hopefully we will get through all of it. All right, so I do have some dates in here. So the fall break is October 16th, so there's obviously no class that night. But if you wish to come here and sit in the classroom and wait for us, feel free, but I will not be here. Okay, the midterm will be on October 30th, and then the final class is on December 11th, and then the final exam is the week after that. So again, just know that. Okay. Now, we may rearrange some of the topics just as we work our way through things, but regardless, these are the topics that we ultimately will cover. Okay. So, how are my exams?
It's good.
It's good.
It's really tiring, actually. You have to do a lot of writing.
You have to do a lot of writing. So if you have not done a lot of writing before you come in to take the exam, you will be shaking your hand and you'll be going, I haven't written this much in years. Right? But was there anything on the exam that we did not talk about in class? Everything was in there, right? So whatever we talk about in class is fair game for me to ask on the exam. Simple as that. Right? So a couple of clues, and you see if the clues are correct, and then we'll let you add anything about what they should study based on your past history. Right? Okay, so if I talk about something more than once, right, that typically means it's important enough for me to repeat. That means it's something that I think you need to know. Now, that doesn't preclude, if I didn't talk about it twice, that it's not going to be on the exam, But again, it's a clue to things that I feel are important. Okay, the second thing is if I say a great question would be, or if I ask a question in class. Right? That's a clue that I want you thinking about this. This is something that you need to consider, right? So if I make a suggestion about a question, and then obviously we answer that question, or I ask a question of the class, it's again something I am trying to get across, that that is something that is important in my mind that you need to know. And so look for the things that we talk about more than once, that I ask you about, right, that we go more in depth on, right? But literally anything that we talk about in class is okay to put on the exam. Is that fair statement? Yeah. Okay. All right. So, kind of the other thing that, did you want to add anything to that? And how to study for it? No? All right. He just doesn't want to give away any of the hints. Okay. Okay. Okay, so the other kind of thing that I think that would be very helpful for you to know is how many questions did we have? Probably 35-ish questions. But the good news is I don't just give 35 questions, because each one has multiple questions to it, right? So I actually end up getting about 100 questions into the exam, even though it's numbered 1 through 35, I get close to 100, because I will say, for example, define the different types of databases. So I'd be looking for a definition of relational, hierarchy, network, and which one is the most popular and why, right? So I'd always add something extra because you guys are always really smart and I need to evaluate. So my clue to you about getting a good grade in this class is read the entire question and answer all of the question. What I take lots and lots of points off for on exams is people skip part of the question. It makes it really easy to grade because you don't have something on there, but it also means that you don't do so well. So before you turn it in, make sure that you can look at every part of the question and find that you have answered it. I will remind you when I hand the exam out, but people will continue to do that regardless. Okay? All right, so the other thing that you will find, and I think you will attest to as well, was in the class I asked lots and lots of times, are there any questions? And what does it mean if there's no questions? That you completely understand it and I can go faster. Because you don't have any questions, so obviously I spent too much time on the stuff that I talked about before, so get going and cover some more stuff. Okay, yes?
What would you like us to call you?
Whatever you want, I answer to anything. So you can just call me Tom, that's fine. You can call me professor, but I'm not a true professor, so that's just a nickname. But if you want to call me that, that's fine. If you want to say, hey you, I answer that, right? So anything you would like, as long as you, I know it's me that you're referring to as opposed to somebody that's in the row in front of you. But yeah, Tom would be fine. All right. Okay, so any questions?
Do we get the recorded sessions of this class?
Yes. So that is new. So they sent out a note saying that everyone has access to all the recordings. It used to be only the online students did, but they said now everybody does. Now, how, when, I'm assuming it's the same as everybody else's. So the unedited one is available pretty much right after class, and the edited version is the following days.
On the campus.
On campus. Okay. So if it's not, the recording people are right upstairs in the building here, so you just head upstairs and go, hey, where is it? Start pounding on the table and stuff, and, you know, get tough with them. But since they sent out the note, I'm assuming that everybody has access to it. Okay. Any other questions?
What's your attendance policy?
What is my attendance policy? So my attendance policy is, you are professionals, should be here, right? You paid to be here, and since anything I talk about, whether it's on the slides or not, is fair game for the exam. And as he will tell you, I don't stick quite so well to the slides, right? And on the exam, things that are on there that aren't on the slides. So it's a great benefit for you to be here. So I am not taking direct attendance and say, were you here? Yes, no, and you know that doesn't factor into your grade. But I will also tell you that historically, people that don't show up, even though you can see the video, being here, listening to it, right? Because what a lot of people will do is get the video and they get interrupted at home. They'll watch a piece of it, come back later and do some. They're doing something while the video's on, and right. So typically they don't do as well. So I'm not going to count you here or not here, but I want to see your smiling face here. Okay. All right, anything else? All right, so let me give you the background on why I can stand up here and you get to sit there and listen to me. All right, so my educational background is I actually went here to U of M Dearborn. And unlike all of you that were very focused, you know what you wanted to do in life and what grade or degree that you were getting and all that kind of stuff, I wasn't so focused as a undergraduate. So I actually have 3 different undergraduate degrees from here. I got them all in the same semester. So when I went to the graduation ceremony, I kept making the rounds, right? Because it was different schools. So I have a CIS degree, and that was not in the School of Engineering at that point in time. So it was in a school on campus called Interdisciplinary Studies. So we got to go up, and I got my Tom Steiner, hey, CIS degree, right? And then when we got to the engineering school, I got to go up again for my industrial systems engineering degree, and they kind of looked at me and I just, okay, I'm here again. And then when we did Castle, I got to go up again because I had a mathematics degree, and they're like, I got 3. Don't ask. So I actually have 3 undergraduate degrees from here, and to show you how long ago that was, this building clearly wasn't here, and there was actually only 5 buildings on campus when I was here, and where the parking structure was where I got to park because it wasn't built yet. And you know how when you go to events, they have the little strings that you get to park in when you go into the fields and park? That's what we get to park in there. So it's really great when it's snow and sleet and rain and stuff. It's all mud there because that's where everybody drives and parks. And stuff. Oh, fantastic. So I also have my graduate degree from here. So I have a graduate degree in industrial and systems engineering. So that is what my graduate degree is. And if someone would have ever said that you were going to teach a course at all ever when I was an undergraduate, I told them they're out of their minds because I would never even speak in class ever. But things happen, and I actually did my first course as an undergraduate. So, and I have been here ever since. So, I have taught here this is my 38th year here on campus. Most adjuncts teach the same 2 or 3 classes, kind of same over time. And with the additional courses that I did over the summer that I had not done before, those were number 67 and 68 different courses that I have taught. So I have done 7 different programming languages, I've done computer architecture, I've obviously done databases, software engineering, networking. The only main topic that I have not actually taught a course in, I've been scheduled 3 times but got shuffled out of, was operating systems. But other than that, I have kind of covered the range of things. So I did discrete mathematics 2, as in for the undergraduates, for the first time this summer. So still doing different ones. So the point I'm trying to make is I have a wide and varied background of courses that I have covered. Now, in doing that, as I said, I've basically been teaching full-time here at the school, but I have a real job outside of this. So when I got my undergraduate degrees, I went to work in industry. So I started as a programmer, and after a year of doing that, then they said, "You want to be a database programmer?" Ooh. Right? So I started working with databases at that point, and that's where I actually I was very fortunate in the job that I had. We were a small contained group within a very large organization, but we got to control our own destiny with our own databases and the way that we did things. So that's where I actually learned how to design and build databases originally. And after a year of doing that, then they said, "Well, that's really great, but we need somebody to do some technical work." It was a warehousing environment, and they said, "We want to use barcode handheld scanners all over the warehouse, and it's not wired for any of this stuff, so we need somebody to go out and figure out how to do that, and none of us want to do it, and you're the youngest one here, you can't say no, so you get to do that." So I spent the next year and a half figuring out networking that I had never ever done before in my entire life, to wire up an entire warehouse so people could work independently of all that stuff. So, and when that project was done, actually one of the people that I worked with when I was doing the database work had left the company and went to General Motors. And that was right at the time when, most of you probably don't remember this, but GM outsourced all of its IT work to a company called EDS, for Electronic Data Systems. And there was a big uproar, and a bunch of people left the company because they didn't want to transition to this new company. So the database group that this person went from 16 people to 4. So I got a call from him. He goes, "You know how to do this. Do you want a job?" I said, "Well, how much does this job pay?" And it was a 80% increase over what I was currently making, so it really wasn't very much of a choice. So I went and became a database administrator. So that's part of why I can do this. So for 7 years, I was a database administrator, handling both relational and hierarchy database management systems, both from a logical and a physical perspective. When that came to an end, because I was a agency or contract type of person there, and they said, "We can't have those at the company anymore." Okay. The group that I actually had left to go there said, "We hear that you're available. Do you want to come back?" Okay. So I went and did that. And I was a business/system analyst, developer, make coffee, wash windows, whatever they wanted me to do at that point. And I got in trouble there. So I got tired of waiting for the database group that we were interacting with to actually create my databases, and having been a database administrator, obviously I knew how to do all that. So I actually created my entire database system offline in the background, allowed me to do all the work and they said, how could you do that? Because we don't know how to do that. And I go, because when they finally got around to it, they said, you can start. And I said, I'm done. And they're like, well, what do you mean you're done? Well, I created the whole thing and it's all built. And they go, you're not supposed to have access to that. I said, well, I'm sorry, I didn't know that I couldn't do that, but I did it. So knowing things is part of the battle. Right? So I got a call one night there and they said, you want a job? I go, what kind of job do you want me to do? And they said, we want you to manage projects in a team. I go, that's nice. Do you have a resume in front of you? Yes. Is there anything on this resume that has anything about leading teams or projects? No. But you want me to do this? Yes. Okay. So I interviewed for the job. I got the job. And you know how you're supposed to have the question at the end of the interview, right? To show that you're interested and all that kind of stuff. So my question was, so for this team that you're talking about, right? So what is the average size of these teams that you talk about? And they go, oh, well, you have the team lead person and 3 to 4 people that kind of work for them. And I go, if I get 3 people that know what they're doing, I can just be the figurehead and go and be successful. So I figured it out. So I walk in and my boss says, oh, here's the structure of my group. So he gives me a little org chart and all that kind of stuff. And then he looks at the clock, he goes, oh my gosh, it's 10 o'clock. We need to go meet the teams. So we get to the conference room and there's 12 people there. And I'm going, oh, isn't this great? He brought all the different teams, right, because I'm thinking of the org chart. And he goes, here's your team. And I looked at him and I go, what happened to 3 to 4? Oh, that's the average. This is you. So I did okay there because I ended up working on that same area of the company for 17 years before I moved. So we handled lots of databases. So that application had over 550 databases. It had over 68,000 variables on those databases. We had 6 different database management systems that we worked with. So large structure, large business. So and we managed that. And obviously, even though I wasn't managing it, we were a part of the design structure of all of that as we worked our way right through that. I am currently, I moved from that about 3 years ago now. So I have now moved into the analytics space. So I am dealing with the big data area now. So I'm dealing with the Greenplum and Hadoop structures and things like that. So it's a very different way of approaching it, but it's even more data and larger scale, and it's great. So, point being is that I have a wide and varied background related to data and databases, and what I have found in teaching all these different classes and dealing with people coming out of school is people don't really know how to apply what we talk about in school. So part of what I want to do to help you understand that is, because I know when I came out of school, I first started and they're like, you don't know how to do any of this, you got a computer science degree, what's going on? Right? And now that I hire people coming out of the CIS programs, they really don't know how to do it either. So I decided right out of school when I started teaching that I would try to bring as many examples from the real world and how we do things and the problems that we run into and the successes that we had to give you a sense of how to really apply what we do. So you'll hear lots of different things about it, but the intent of that is to not just give you academic or theoretical approaches to it, but concepts on how to really apply what they do. Okay? So, with that, that's probably more than you ever wanted to know about me. Okay? All right, so any questions now? Nobody's running for the door, so that's a good thing. Yes, sir.
Will that be on the exam?
It could be. And I could ask, what are all the things that you could call me? Could be on the exam.
Fair.
Anything we talk about. Is it likely to be on there? Probably not. But could it be? Yes. And your name?
I'm Cooper.
Cooper.
Nice to meet you.
Nice to meet you. And it'll be very easy to name because one of my favorite business customers was Mr. Cooper. So that will stick in my mind. So thank you for having a memorable name.
Anything they could do.
So again, please feel free to answer or ask any question, right? This is your class. This is for you. You are here to learn, right? So as long as it's related to database, if you want to take us off on a different kind of track to answer some question or to look at something, we can do that, right? There is nothing to prevent us from doing that as long as we are covering database systems as part of this class. So if you guys have a particular topic that's not listed, feel free to suggest that. If you have a question of just how something works or a way to approach something, feel free to do that. Right? This is your class as well as my class. So feel free to approach it that way. All right? All right, so again, what's no questions mean? You have talked too much, get going, get on to the next topic, right? All right. All right, so let's talk about databases and database users. All right, so one of the things that we want to talk about is the fact that as data really, well, first off, what is data? Oh, wrong. You state that on the exam. What am I going to give her if she states that? A negative. Negative score, right? Data is not information. So thank you. I know you just said that just to get me riled up, right? Okay, so, no, but thank you, right? Because that is a very big misconception, right? So data is a set of facts, right? That's the way you want to think about it. Data is a fact. If I say the number 1, we have 1 assigned textbook for this course. 2, you will be taking 2 exams in this course, right? It's a fact, right? But what do we store? We don't store 2 exams, 1 textbook. We just store the number 2, or we store the number 1, right? So that's the data. So the data is the fact. So changing data into information. So data is transformed into information. So it's taking that fact and making it into something that is meaningful. It has context. So I have in my database or in my file the number 1, and I show on a screen that it means 1 textbook. In the database, I have the number 2. What does that mean? When I show it on the screen, I say 2 exams. I've taken a piece of data or a fact and I've translated it into information. So that makes sense? Okay. So it's important for us to understand data, and it's also important to us to know about information and what do we store in databases? Data, right? We don't say information bases, we talk about data bases because we are storing facts. And when we present things on a screen, right? When you order things on a screen, because you guys have all probably done online ordering from stores, right, or e-commerce sites, right? They don't store the fact that your say your first name and you say Cooper, they just store Cooper. And we know that that particular piece of data represents the first name. And if I extract that piece of data for it to be used, so I know whether it's you, Cooper, or it's my Mr. Cooper, I need to know whether it's the first name or the last name piece of data. Right? Because if I just see Cooper, it could be either. Or it could even be a middle name. Right? We don't know what it is just without any context around it. So we have databases because we are storing data. And we have to be able to extract that and store that or show that data as information for people to use. Now, Cooper, let me ask you a question. Does that sound like something that gets me like really riled up that would probably be on an exam, for example?
Yeah.
Yeah. So I would think that that might be a really great exam question, right? So how does data relate to information, or what is the difference between data and information, right? So something like that would be an example of a question that would be, so my exams are all relatively short answer, right? We will have some, because we are doing some modeling and things in here, there'll be some aspects of that will be on the exam, just like you kind of as doing yours. But in general, they will be short answer. Okay. All right. So, how long has data been around? Forever, right? We didn't have databases. We could have stored electronically, but we stored it whether it was written on a sheet of paper or right somewhere, right? So data's been around forever. So what's the purpose of a database? It's to gather data into one place and make it accessible in an organized way. Right? So when we talk about traditional applications, right? So numeric and textual databases, right? So if you go back historically, all the original databases were all about storing data that was number or some characters, right? So I had an account number and I had a first name and a last name and an address, right? Stuff like that, right? Right. But now, with the advent of the explosion of the types of data that we have other types of applications that we encounter, right? So multimedia databases. So what's multimedia about? Right? So that's your pictures, videos, things like that, right? So we have to have a way to store those as well, right? Okay? Because again, we do lots of things like that. Okay. The geographic information system. So what's that about?
Polygons.
so it could be polygons, right?
Maps.
Right, so a lot of it's maps, right? So we use the geographic information systems, for example, to predict one of the things that what do you think we're predicting right now related to weather?
Hurricane.
So impact of the hurricane, right? So companies want to know, what is the impact to that? What is your expected damages that you're going to potentially encounter? What is the probability that you're going to encounter this? Okay. So we have things related to that, right? So biological and genome databases, data warehouse. What's a data warehouse? What the heck is that about?
All the data is stored.
Yeah, don't we store data in databases?
It's a collection.
Collection of databases, excellent, right? So what's a warehouse? It's a warehouse where we put all kind of stuff together in one place to be able to then disseminate that out. So we gather it in and we send it back out. So our data warehouses are literally about bringing data in and bringing data out, and when we bring it out, we turn it into information. You guys need to be a little quicker at that. Yeah.
Is retrieval enough to transform data into information? What's the threshold? If we talk about Cooper being just data and first name Cooper being information.
So extracting data is a piece of it. It's the most basic piece, right? Because you're not making any transformation of Cooper. I just put on the screen that Cooper is his first name. So if I look at a list of all these students that are registered for this class, I would be able to look, after they're all extracted, look in the first name column, and I should find Cooper. And if not, what do we know? He's just kind of hanging out here just because he thinks this is the cool place to hang out, and you're really great to hang out with. But I think you're registered, right, Cooper?
Yeah.
Yeah, okay. That's what I thought. Okay. Now, we do extract data and then have to transform it in some way. Okay, so what might be an example of that? Okay, well, if you look at companies, for example, right? So I would say that most of you have a credit card somewhere, right? So therefore you have a credit history someplace. And how many main credit bureaus are in existence? 3. So Experian, TransUnion, and Equifax. Right? And each one of those gets your credit data from your use of the credit card. Right? And each one of them has a set of codes that they have on the status of your account. Okay. And what do I do? If I retrieve your credit history and I store that in a database, I either have to, on the way in, transform the data to say, because each one has a different status that means the exact same thing, I have to translate it into my common one and store it as a piece of data, or on the extraction process where I'm going to display your credit history on a screen, Cooper, right? I have to translate it so that it's one entry on the output that says highest credit rating ever. Right? So there's times that I have to store it one way and transform it coming out. I have to, right? There's, if you place an order, I don't necessarily store, for example, the data that is the sum of all the items that you ordered, because that's what we call derived data. If I can derive it, is there really a reason to store it? Because what happens when you store something. There's a cost to it, right? You have to buy memory. Well, it's not bad if I have 10 customers and 10 orders that I am keeping track of all the derived data. But if I have millions or hundreds of millions of them, now I have to buy all this extra storage to handle things that I can derive. Right? Does it make sense to do that? Some people want that because they want the security of knowing what that is. Other ones will say, anything derivable, you don't save at all, because we can re-derive it if we need it. So, long-winded way to answer your question, Cooper, of it depends. Right? So there's times that we pull things out and we calculate derived data to show on a screen, so it's another piece of information, even though it wasn't in the database, but it's derived from the database. It could be something that we directly pull and display. It could be something that we pull and we transform and display the result, I think, as our example. So Cooper, did I answer your question?
Depends.
Okay. But we're okay.
Yeah.
So move on
Yes, please.
and go faster. Okay. All right. So mobile databases, real-time and active databases, right? So, right. What the heck are mobile databases? So typically, your standard databases all reside where? In some part of the company, in your data center. What happens if it's in the cloud? The cloud exists as a location somewhere. It's just where a big group of companies are using a shared service. So it's still at a location. A mobile database is, hey, you're moving it around with you. So it's on your phone and you are taking your phone wherever you go, so it's mobile. Okay. Or I can move it to different locations. What's real time about? If I have a real-time system, what does that mean? It's what?
No batch, just,
Yeah, well, okay, we'll get to batch later, but thank you for bringing it up. So that's actually the next question. So, real-time means you are acting instantaneously right now. So you are clicking on the submit button and you are getting a response back. Okay. So what that means is if I'm doing all this data to, for example, get all the list of students in this class to see if Cooper's really in this class or not, I'm going to click on give me the summary class list of all these students, and I expect a instantaneous response. So that's a real-time or active database. Okay, so what's a batch? Since you brought it up, see, that's really good. See, when he asks, he must know. He's trying to see if I know, but I'm going to ask the question back.
so if you have a certain set of processings which takes a long time and cannot be executed during real time for performance reasons, they combine all of that and run it as a batch. For example, like a bank transactions where they have to update a lot of their books, they will do it as a batch as opposed to doing it on the real-time manner.
Oh, you are so close. I'd give you full credit for that one. Okay, so he mentioned several things, so I want to hit on those because they're really great points. Okay? So batch means we group things together and we process them as a batch or a group. Okay? And one of the reasons that he said that we might do that is because we can't do this in a real-time process because of performance reasons. So that is one of these scenarios. Okay. So batch, there is actually a tremendous amount of batch processing that we do against databases. Okay. And the reason is because, guess what? We do a lot of work related to databases. And some of our databases have not hundreds of records on them, we have hundreds of millions, sometimes billions of records. If I have a 300 billion records on the database and I have to go through and update those, it's not going to be a 3-second process. Right? So we're going to run some sort of batch process to do that kind of things. Okay. But it's not always because of performance. And this is the point I was just trying to make, right? Is a lot of times we have business processes that are going to drive us to have these processes take place this way. All right, so how many of you do online banking? Okay, and what happens if you go out to look at your account right now? What are you gonna see? For anything that you did today? What's it gonna show?
Some processing.
Right, it's gonna be pending. So why is it pending? Why don't they apply it right away? Because it's, right, you use your charge card or, right, you withdrew money or put money in, I should be able to do it instantaneously, because you just did it. Why do they put it as pending? We wanna wait, but what do we wanna wait for? Oh no, it's already approved. That stuff is gone. Right? Right? But, right? What happens if your account goes negative? And you get a fee, right? Okay? And what happens if the deduction occurs before you did your deposit? So, you have $50 in your account. We know you got way more than that, right? But you have 50, right? And you take and do a transaction that is for $100 comes in, right? And you knew it was going to happen, and later that day, before the end of the day, you put in $300. Right? What the bank doesn't want to happen is you get charged an overdraft fee because you had money on the same day. Right? So what banks do is, at the end of the day, they take all of those pending transactions and they order them. So all of the deposits that go into your account go first, and then they deduct everything after. Right? So it doesn't matter what time they happened, because they don't want the customer calling up and saying, I got this fee, I put money in, what are you guys doing, why are you messing with me, right? They want to avoid that. So we process, from a bank perspective, we don't do it because of performance, we do it because we want to keep customers like you happy, right? Okay, what other things might happen? You order a bunch of stuff online. They don't immediately go out and fill that order and send it out. Why not? They want to be very effective in the way that they send people around the warehouses and pack them all up and all that other kind of stuff. So they will gather up all of the orders for the day and they will arrange them so that they can be picked most effectively through the warehouse. So we run a batch to say, if I have person X going to this location, I want to pick all the things that were ordered of that item at one time, not have to go back to that same location 30, 50, 100 times over and over again because I have 100 orders that ordered that same exact thing. Okay. So business practices drive us, not just performance. So performance is clearly a piece of this, but we want to be very effective as the way that we run our business. Because every time that we do anything with people, processes, there's a cost associated with it. So, understanding that is going to, because, right, and the reason that we're talking about this is part of the decision that you make when you design databases is what is the way that you're going to use this. So there are databases, for example, that you would structure because you're doing this batch type of processing. So in general, right, not always, but in general, your hierarchy databases tend to be faster when you're doing batch than your relational. Right? So if you don't understand it, you would just always create relational because that's what everybody does, because that's the cool thing. Okay. We also have, we talked about real time. What is real time again? You're going out and just getting something. I want Cooper's account. Go out and grab it. Right? Well, I'm not searching the database through all of them. I'm not updating anybody else. I just want Cooper. So if my process is only real time and I'm only going out and getting one thing at a time, I'm going to design my database very differently than if I have these batch processes where I'm working my way through and I have to look at the majority of records or a bunch of records that are in the same area, things like that, right? So what I'm trying to get you to understand is for us to be extremely effective in doing database systems, we have to understand how the data is used. Because anybody can create a database. Is it going to be the right database for the right job? That's what we're trying to get across here. Right? So, lots of different uses for all this. Right? So, social networks capturing lots of information about people. So, is that a correct statement? Is that a correct statement? No. 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 What should it say? Data. Right? So again, even your textbooks, all of this stuff, right? So this is directly out of the textbook, right? Okay. Social networks started capturing a lot of data about people and about communication among people, posts, blah, 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 right? It's data. Data gets turned into information, right? So if I put a statement like this on the exam and say, is it correct? You better tell me. No, and then you shouldn't have to even think about it. Instantaneously, right? We store data, we transform data into information. Like fun, right? Yeah. Right. So, again, my main point I'm trying to make to you is textbooks, instructors, right, students, people that you work with, they are all going to interchange data and information. And it is inaccurate, but you will see it everywhere. Okay. Right. So then we come down to the bottom. Oh, all of the above constitutes data. Well, yes, it does, because that's what we're really storing is data that ultimately gets turned into information when we put it on a, right? So when you go onto Twitter and you see the tweets, it's in context. You are on a screen. It's from somebody. It's, right, you have a context of what it is. So now it's a piece of data. How is it stored internally on the Twitter databases? They don't store it in the way that's on a screen. They have the user, right, so they can have some sort of key. They're going to take the time of when it happened. It's going to have the context of what it's going to be in there, right? right? That's the data, but we translate that into information by the way that you get to see it on the screen. Okay. Okay. Right? So we have search engines, right? So they collect their different repositories of web pages for searching. So why do we have to do that? So let me ask this question. How long are you willing to wait for a web page to come up on your screen?
0.
0, right? But we wait a little longer than 0, but not much.
Epsilon.
Right? We all want it really fast, right? But how many web pages are out there? Trillions, right? Right? Well, guess what? When we search, you expect this instantaneous response with, right, all the things that you are looking for with 0 time. Right? So, when we have search engines, they collect their own repositories of the web pages that they can search internally. They don't go out to all the different external sites to find them, right? Because you expect it fast, and if you are not getting it back fast, where are you going to go? You're going to switch to a different search engine, right? So, right, from a business perspective, they've had to say, how do we search things? How do we store this? How do we get effective use of the way that we are doing this? Okay? So, we have new technologies that are emerging from so-called non-database software vendors to manage vast amounts of data, right? Okay, so what the heck are we talking about there, right? Okay. Software is being generated at a tremendous pace, but all software depends on what? Data. Right? Every process has some sort of data as its input, information as its output, and some sort of processing in between. Right? So we have to look at what is the data that we have and how do we process it in the most effective way. So there is a large number of companies, and that's why this is here, that they have their own proprietary data management in terms of databases. So, for example, my team uses a statistical language called SAS. Okay, and we have SAS databases. So it's a proprietary data storage mechanism of a type of database, but it only works within the SAS environment. So SAS programs can read SAS databases. Now we've made it so that some of our non-SAS programs can read it, but it's not as efficient, right? Things like that. Right? Okay. We talked a little bit about the fact that big data is out, right? Ooh, big data. We never called anything little data, right? Okay. But what's big data? Large amounts of data that we're going to be storing and managing it, right? So what is coming that is going to just burst all of our concepts of big data even, in terms of data that we are going to have to collect and process? What's going on right now that is going to generate more data than we have ever had to deal with at all?
Autonomous vehicles.
Autonomous vehicles. That vehicle has to understand everything that's going on around it. It has to make decisions based on every piece of data. It has to gather data at every single second, not even at the second level. It has to be going faster than that. And we end up storing that data because right now, for us to test it, we have to analyze what happened. So we are storing terabytes and terabytes of data about a single vehicle, and now you have 500, 1,000, 2,000 test vehicles that you're gathering data on all at the same time and storing this for future reference to see how it's working, make adjustments, run it again to see what happens, compare it to the old stuff, right? I mean, we're just running right rampant with the amount of data that we are storing in that environment. And we are still struggling at how we're going to do this long term. Okay, we have the no SQL, so not only SQL systems. So SQL stands for Standard Query Language, right? So most database management systems use that, right? But there are systems that we've migrated to not using that. So, right, so again, it's non-standard way of looking at it. So structured or non-structured, right? We end up with both in that kind of scenario, right? Okay, so again, I always love these. A large amount of data now resides on the cloud, which means it's in huge data centers using thousands of machines. Ooh, right? So all you're doing is you're hosting it someplace, right? So the really great thing about all of this stuff is it's all new and nothing has really changed over time. Okay? So you have a wonderful computer there, right? So did you buy it recently?
Yes.
Yes, okay. You like it?
Yeah.
Is it really fast?
Yes.
Right?
So
So far? Okay, so when was the architecture of that computer designed? It's a quick trick question, so it's okay. So when do you think that was designed?
1940.
Probably 1940, 1950, right? So the von Neumann architecture for computers is still what we use today. So it's old, but oh, it's really fast and it's really cool and this is really great and oh, man, this is just the best. We just figured out ways to make it go faster. We've had data forever. What are we doing? We're putting it in places that we can get to it and process it faster than we have before. Right? Huge data centers using thousands of machines. Back in the late 1960s, early 1970s, we had a process called vendor hosting. Not a very exciting title, but it's where a company could contract with a company and store their data there and process it just like the cloud. Wow, do all the same things that were the cloud, but it wasn't really good then and nobody thought it was going to be like catch on and right. But somebody called it a cloud, which is a whole lot better than vendor hosting, and now it's like, wow, that's a really cool thing and I want to in on that because it's really great. So all the stuff that we have in computers, it's old but it's new. So you had a question or comment?
yes, I want to ask if we can add SAP HANA as well in this list. Can we?
So why would you want to add that?
Because, like you said that we have databases. Now the recent developments have big data storage, cloud, not only SQL systems. Similarly, SAP HANA is serving as real-time application as well as enabled database.
Mhm.
So most of the business are migrating from having a physical database, migrating their systems from having a physical database to SAP HANA.
Yeah, right. So you're absolutely correct, right? So there's lots of ways that companies are improving on things, right? So we have, and you mentioned it, right, the concept of in-database processing, right? So since you said what is it?
So it is like a high availability real-time application as well as database, SAP HANA.
Right, but what does in-database processing mean?
So,
If it's just that term, not in terms of any specific way that it applies, because you can do lots of in-database processing from lots of different ways. Right? The concept is that what do we typically have? You have data stored in one place and you bring it to someplace to process. Right? And what happens when you have to move something from one place to another? Time. Right? And how long are you willing to wait to do anything? 0. Right? So, in database processing is the concept that I'm going to take the processing that was done over here and I'm going to bring it to the database. So, I am doing the processing at the same place that the database is, to eliminate all of that transfer time that brings no value because you're not doing anything while you're waiting for all this stuff to happen. So, in answer to your question, yes, we could add multiple things to this as technology is rolling. The idea of this really is just to highlight some of the things that are going on.
You just mentioned in-process database. So, by processing, do you mean that business logic or what exactly?
Yeah, right. So the question is what kind of processing are we doing? So yes, it is business logic, right? Doing utility type of logic, doing analytics against it, whatever it happens to
So
be.
that would be very specific to the business or to the application for which it is.
Yes, right. Now, what we're trying to say is that from a company perspective, you want to make it so that you have the capabilities, and then, once I build the capabilities, then you can decide what is the way that you're going to approach it. So, like for us right now, one of our big issues that we are dealing with is we are starting to apply machine learning algorithms. But to do that, I have to process a lot more data to do that. Where before it was 1 million records, well now I want 100 million, 200 million to do the exact same thing. And instead of having 68,000 variables, I want 68 million variables, right? So, I mean, it's just exponentially bigger, but I want the results even faster than what I was getting before. So, how do you build an architecture around this, where the data is going to be, so that you can retrieve it and process it in whatever mechanism that you are looking for? And so, as an example, one of the other things that we are struggling with is we have, from one of our applications, we have literally millions of really small files. So, like 68, 70,000 bytes of data in each file, but I have millions of these. And I have to process all of them as individual files to get the results I want. And our first thought process was put them all in Hadoop and, right, it will just magically all happen. And it will once it's there, but the struggle we have is how do we get the data from its current location into the Hadoop environment? And we're estimating that to do that is going to take us half a year. So we have to come up with some other way to do it, because Hadoop isn't made to handle all these little files. It's okay once they're there, but getting them in and structured, right? So it's capabilities like that that you have to consider the whole entire picture. So point being is that we have lots of new developments that are happening in the data world, and you pointed out, so there's other things that we can add to this, but the idea is that we're just really trying to say that there's lots of things happening in that environment. Right? So, some basic definitions, right? So, a database is a collection of related data. Right? So simple as that. Right? Data itself, right? So we said that was a fact. Okay? And what's it get turned into? Information. Okay? You guys are getting a little faster at that, but. Okay? Okay, we have the concept of mini world. I love this. Right? Some part of the real world about which data is stored in a database, for example, student grades and transcripts at a university. Okay? So, the only place I have seen this whole mini world concept is at school, right? So in your textbooks and things like that, right? So all you're really trying to say is that the real world is represented by facts. And we deal with things in the real world by getting information and reacting to the information that we have. So our mini world, what they're talking about here is, I'm segregating part of the real world into this system that we are dealing with that has facts and information that people can work with. Right? Simple as that. Okay? Okay, our database management system, or DBMS, software package or system to facilitate the creation and maintenance of this wonderful computerized database. And why do we have these? Because we don't want to have to create our own, right? So, are you going to pay a lot of money for a database management system? Maybe. Right? Microsoft Access, you're probably not going to pay a lot of money. You buy a Teradata system, you're going to pay a lot of money. Right? So, the whole, as Cooper would say, it depends. Okay, the database system, so the database management system software together with the data itself, and sometimes the applications are also included. I would say in the real world, when we talk about database systems, the applications are always included. Every place that I have worked at, and I have worked at companies where I am one of a cast of thousands. I've been at companies where I have been in the cast of 100, and I've also been at a company where I was the only IT person in the entire company. And it didn't matter, wherever I was at, when we talked about our database system, it did include applications. So when they say sometimes, I would say it really should say most of the time. Okay, so when we talk about the impact overall, right? So it doesn't matter, right? So they have all these different places listed, but in general, data occurs where? Everywhere, right? So no matter what you come up with, right, you're going to find data. And if I have data, I can create a database. Simple as that. So whether it's business, service, education, right, as we talked about, all these other areas of social networks and environmental, things like that, right? And again, kind of your mobile, your personalized applications based on mobile devices and things like that, right? So everywhere you go, you're going to find databases and the actions associated with those. And again, what do you expect to happen with these? Speed. It's got to be fast. Right? Has to be accurate, all that goes. So when we talk about a simplified database system environment, right? So we have our database system, right? So you have the users on the outside, the database system, which includes the application, right? The database management system software itself that's going to process the scenarios that are passed to it for either our queries or our programs. We have to access the data itself, and we have the database definition, which is what's called the metadata, and we have the data itself that we're storing. Okay? So let's talk about this just in real quick terms. So what's an example of an application? When you registered for this class, you went through a registration system. What did it do? It took your data as a student, combined it with the course you wish to take, and stored that data in the database to say that Cooper is registered for this class. Okay? And we have the database management system software that is managing that. Why? Because we don't want to have to manage it. Right? If I have thousands and thousands of programs that are accessing a database, I don't want to have to write access software in every single one of them. I want to use my structured query language command to go out and execute against it and process it. So your database management system is taking a request from the application, verifying that it can do that, go out and access the data. So when I want to access and say, where am I going to go get it? I have to know the layout, how to get to it, what's its definition. So I have to use the metadata to determine how to get to it and how I'm going to process it. And then I have to actually physically go and get it. Before I can store anything out there, I have to create the database definition. Otherwise, I can't store it anywhere. Okay? If I'm going to delete it, I have to delete the data and then I delete the definition of it, right? So we have to, there's a full cycle associated with this. If I want to understand what my database environment is, this database definition is going to tell me how all the pieces are related to each other. If I want to see how it's performing, I need to look at how the storage is working, right? So from a database management perspective, we are looking at the application, we're looking at the database management system, and we're looking at the metadata and the data itself to understand how it all plays out. Any questions? All right, so our database management system functionality, so we have to be able to define databases in terms of data types, data structure, what constraints that we have on it, right? We have to be able to construct it or load the initial database with data. We have to be able to manipulate it. And what we mean by that is retrieve the data. I need to modify it, so insert new data, delete data from it, update data that's in it. And I need to be able to have some way of accessing it. And they talk about it from web applications, but it can be from literally any application. Okay. And processing and sharing. This is probably one of the biggest areas that we have issues with. Okay. And it's because we are processing and sharing a set of concurrent users and programs, keeping all the data valid and consistent. So what could be a problem with that? You pull out a record to update it. Cooper wanders over to you and says, hey, let's go get some coffee. You go, hey, that's a great idea. So you go off to get some coffee, but you've got this record pulled out to do some update on. What if somebody wants that same piece of data? What do? Do you let them have it, even though he's got it pulled out for update? Do you say, you can't have that till you come back with Cooper and you make the update and save it? What if 5 people want that same piece of data at the same time for update? Do I just want to read it, right? So processing and sharing is a big concern for us from a database perspective of how we're going to manage that. So you have ways, for example, when you go into your structured query language, that you can say, go get me that piece of data even if somebody else has it out for update. Even though they haven't updated, just give me the record that exists out there. I'm not going to wait for the update. I can also say, I need to wait for that update to occur. So you keep trying to get it, and after a certain amount of time, you come back and say, you can't have it because it has been updated in a reasonable amount of time. Right? So we have ways to access data and process it, but unless you know how it's all going to work, you can't design it very well. So again, our big thing that we are trying to get across to all of you is understanding all of the things behind the database is fine. It's really great. But none of this is really going to matter unless you absolutely know how the data is going to be used. What are your constraints on it? What's the way that you can approach it? What if these scenarios happen? How do you want it handled? Because we can design databases, we can design applications in lots of different ways, but you can't do that unless you know all the detail behind it. Okay, so application activities against the database. So our applications interact with the database by generating queries, right? So different parts of data. So what happens in a query? Do we update anything? No, query is go get data and bring it back, right? I'm not transforming anything from the database perspective. I can bring back and I can derive data, things like that, so I can do calculations and all that kind of stuff. I can count things, all that kind of stuff, right? But the underlying database will never change with just a straight query. Okay, so a transaction may read some data and update certain values, right? So again, if I'm going to store it, I have to update it, and now that gets back into that whole, what about me processing it versus other people wanting it or other people wanting to update it at the same time? So how do we share things? Okay, we have to have security around our data, right? So how do we keep unauthorized users from accessing the data? And again, we're going to, what about the world? The world is constantly changing. So that means your data is going to change. The way that you process the data is going to change. The way that old data versus new data and potentially needs to be merged. All of those things are going to be taking place. So you have to keep up to date on it. Okay, so other things that can happen is protection or security. Right, so we talked about access, so we have active processing, right? So internal actions on data, we have to do presentations. What's visualization? What's that about? Pictures, we love pictures. Nice graphs, nice dashboards and all that kind of stuff, right? Those have been around forever too, but now it's a cool thing. Okay, so we want to be able to provide some of that. Maintenance of the database and associated programs, right? Okay. So, what types of wait, we talked about maintenance in the other class. So, let's test you. What are the 3 types? Oh. Okay. So, can I help you out? Okay. So there's 3 types of maintenance that we deal with, right? And maintenance, to take a step back, maintenance is things. Once I create something, I need to maintain it, whether it's updating the data, updating the applications, right? Business conditions and economic conditions, the company functionality, right? Change all the time. Right? And our databases have to change in an associated way. So we want to concern ourselves with 3 types of maintenance. Right? Remember there was 3, right?
Yes.
Yeah, okay. So the first one is corrective. And what does corrective mean?
Fixing bugs.
I have a problem with the database, there's a problem with the data on the database, I need to correct it so that it is correct going forward, right? So we have to maintain things so that things are correct. And we want that to be 0 corrective actions if we can, but we don't do so well at that. It actually tends to be one of the higher ones. Okay, so corrective is the first one. The second one is perfective. So what happens if you perfect something? You make it better. So you add new functionality, you do a new visualization, you add new data to the database. Right? So you're making it better. And that's the one you want to do the most of, because you're adding things to make things better for the company. Okay? And the third one is adaptive. And what do you think adaptive means?
Adapt to whatever comes up, to the situation as.
Well, what kind of situation?
Depends upon what your use case is, so.
Not really. But I like the way you're thinking now. Right? Okay, so what we mean by adaptive, because I think what you were kind of saying was I need to adapt to situations in the company. Right?
Yeah.
If I'm doing that, then it's going to be corrective or perfective. Right? What I mean by adaptive is I get an upgraded version of my database management system. I get a new version of the operating system.
Technology.
Right, so technology upgrades, right? New types of servers to store it on. Okay. So a lot of times when we do that, we have to have projects that are going to adapt our current databases to new things, right? So we are in the process of upgrading our relational database management system, and we have loaded it out onto the system. We've loaded some of the data from the current system on it. We're trying it out, make sure it's working okay, because we can't just flip the switch and hope that it works. That doesn't work very well, right? So we have this huge project that's going on to do that. So it doesn't happen that often, but when it does, you need to handle that. Right? So does that help?
Yeah.
Okay. Right. So the 3 types are, right? So does that sound like a really good test question? I think that's a really great one, right? So that's going to be describe them and potentially give an example of each one, something like that.
What's that active processing to take internal actions? The second bullet?
Yeah, right. So, okay. What does internal actions mean? Internal to the company or internal to the system. Right? So, what we mean by active was that's kind of our real-time processes. So I need to make adjustments on the fly because it's active mode. Right? And so we have things that go on, for example, that automatically happen just based on, for example, the time. Right? So one application I worked on we had a process, so nobody personally did anything, but every half hour, a sequence of actions took place. So that was all internal, but it was active from the perspective of you're requesting the database management system to do certain things. So, kind of if you want to think about it, right? What did we describe earlier about your bank example
Processing of
of a batch, right? So probably somewhere around 1 a.m. It kicks off, you get the message, you can't look at any of your account data because account maintenance is going on. And as long as account maintenance, being the active processor that's internally going on, is running, external people can't get to it. But when it's done, you go out there and nothing's in pending anymore, everything is processed. So it's that kind of stuff, okay? Right. So if we look at our example of a conceptual model, our mini world, right? So part of a university, we had entity. So what's an entity? It's excellent. Ding 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 ding. Excellent. Right? It's very simple. It's a thing. Right? It's a thing we're interested in, and it's got characteristics about it. Right? So that's exactly how I want you to answer it on the exam. It's a thing, right? You got full credit for that one, didn't you? Yes. Right? Okay. So we have physical and we have logical things. Right? So a student, is a student a physical thing? I see you. Right? Okay. Can I see a course? Show me a course.
Oh, you mean right now?
Right now.
No.
How would you show me a course?
I feel like it's illegal.
Huh?
I feel like it's illegal.
Well, okay. So if you go to, okay, we'll get off this course thing, right? So, do you have a bank account?
Yes.
Can you walk, here's what I want you to do, Cooper. So your job between now and next week, okay, is I want you to go to the bank. So you have to physically go to the bank, and you have to say, I want to see my account. Right? And what are they gonna do?
Print a receipt.
And you're gonna say what?
Thanks.
No. You're gonna say, that represents my account, I want to see my account. They're gonna show it on the screen. And you're gonna say, that's not my account, I want to see my account. They can't show you to you because it doesn't physically exist.
I heard corpse, not course. I got you.
Or,
I see what's going on.
okay, so a great exam question is gonna be, what's Cooper's version of course? And you're gonna reply? Corpse. Okay, if you guys get that one wrong, because I told you that could be on there, if I ask that and you get it wrong, I got no sympathy for you. Right? Corpse. Right? All right, so sections of courses, departments, instructors, right? Those are all things, whether they're physical things or logical things. And are they related in any way? Students take courses, courses have sections, departments offer courses, instructors work for departments, instructors teach courses, instructors teach students, right? We have all these different relationships that we can define.
departments, do you call it logical or physical? Department.
Can I hold up physically and say, this is the department?
You can't.
And it's logical. Where does the department reside? Over in that building. And you walk in and you just mysteriously walk into the smoke-filled vapor and say, I'm in the department. Right? No, they can't show it to you, right? Right. Now, you can say, people are a member of a department, right? So an instructor is, right? You are enrolled in a department. I can show you representations of that, but I can't show you it physically.
The building of department happens to be a physical entity, but department is still a virtual.
Right. So the way you want to think about it is can somebody hold something up to you and say, this is it, not a representation? Right? So can Cooper hold up a corpse, right? Or can they just hold up a plastic version of one and say this is a corpse? That represents one, it's not a real one. It represents one. Right? So, thanks, Cooper. You know, this is the stuff that I always remember, and I love to tell stories on. So you're going to live on forever. It's going to be great. All right, so sections are of a specific course. Students take sections. Courses have prerequisite courses. Teachers teach sections. Courses are offered by departments. Students major in departments. Right? Okay. So these all come up in an entity relationship data model. And you love those, right? Yeah, it's great. And guess what? You get to do it again. But the good news is I'm going to give the same assignment, so you've already got it done. How's that?
Oh, cool.
Is that fair?
That's cool.
Okay. So if I give you the example, you'll look and you'll be able to give me the answer just like that. But I won't let you do that because they have to do it. Is that fair? Okay. Right. So entity relationships are, I have entities which are what? Things, right? And things relate to other things. And we want to understand that, right? And when we model this, right? So the key word here is model. We want to model a lot of things. That's what databases are about when we look from the logical perspective, is we need to model real life situations. So when we build our entity relationship model, right, we talk about it in terms of databases, but there's actually two versions of it. So when we get to talk about those, unlike most database classes where they talk about one version, we'll talk about two. That'll be great. And I have an expert right here to help me with it. So thank you in advance. Right? So our simple database, we have our course number, credit hours, department, sections, identifiers, right? So we have the thing and we have the characteristics or attributes about each of the things. And then we have instances of those. Right? So it's really simple. I have a course entity, which is a thing. What do I know about the thing? It has a name, a number, a credit hours, and a department. Those are the only characteristics I have about the thing called course. How many instances do I have? I have 4 instances that I have in my database. And what do I know about these? Right? They relate to other things, right? So my sections, right, are going to have to match to the course number can only come from the course entity, right? Because I have to have integrity between these, right? So we'll be looking at how all of those are defined. Okay. So the characteristics of the database approach, right? I always love self-describing. Isn't that great? I love self-describing. All my database or all of my programming classes, I don't have to do any documentation because my code is self-documenting. So. Okay. So a database management catalog stores the description of the particular database. So structures, types, and constraints, as we talked about. We said it was defined as the metadata. Ooh, cool term. Okay. And it allows database managers to work with different database applications because the applications come to the metadata to find out all the characteristics of where the data is, how it's structured, constraints about it, and then it uses the database management system to go access it and bring it back, right? So you're using that as your process. So we have this insulation between the programs and the data. So it's program and data independence, right? Because the database management system is the insulating piece in between. Because do you want to have to know how it's all structured and constrained? No, you just want to access a certain piece of data. Okay.
One question on the metadata
Mhm.
figure. So in the metadata, do you have location of the elements? For example, from where to where does this element reside? For example, let's say you have a table with IDs, and in the metadata, does it say like, okay, 1 to 20,000 is here, 20,000 to 40,000 is, does it say anything like a references?
Okay, so
To accelerate search,
yeah,
that's what
yeah.
I'm
So Cooper, what's the answer to that?
What was the question?
You just use your standard answer.
It depends.
Excellent. Right? Okay. So it is going to depend on the database management system and what their metadata is actually holding in it. So there isn't a standard definition of what is in a metadata. It's going to depend on what database management system you have. So the metadata that you have for a DB2 system is going to be different than a SQL Server, than a Teradata versus a SAS, right? They're all different. Okay. So, in answer to your question, it depends, right? There is going to be some place that is going to define that, whether it's part of the metadata itself or the metadata in conjunction with this other location that describes where it's at is going to do that. It could point to a structure that is completely independent, that identifies the range of where it's at, right? And sometimes it doesn't even do that, right? So, as an example, right, you can have a database management system that just says, I'm storing data starting at this location for this many bytes. And that's all you know. And then there's a randomizing routine that will say, based on this key value, go to location X. So then you don't even have a beginning and a end, per se, stored anywhere. Right? So, as Cooper would say, it depends. That is the favorite phrase in IT everywhere. So, thank you for bringing it up. Okay. Right? So, there are some systems that don't even have any metadata. Right? So, your no SQL systems have that, right? So, right, they store the data definition within the structure so that it's all in place. So you know where the structure resides. So you go to the header of, right? So if you think about headers in your standard file systems, right? It's got information up front that describes what type of file structure it is, things like that, right? So that's what those types of formats do.
So in the class, in the future session, do we cover anywhere where metadata more details?
Mhm.
Okay.
Okay, so this is kind of the metadata description, right? So again, this isn't showing kind of the where it is, but it's what it is, right? So this is an example of the metadata data itself, right? So we have relations, right? So our relation is the things, right? So in this case, student had 4 pieces of data associated with it. Course had 4 pieces of data associated with it, right? Section had 5 pieces of data, right? So how many relations or things do we have in terms of different pieces of data or characteristics do we have associated with that particular relation or thing, right? Okay, and then, right, I have to have, here's my columns or those associations, right, the characteristics, right? So I have this whole list of them, and each one of these has a data type associated with them. But then I have to say, where does it belong to? Because I could have name, for example, belonging to student, instructor, employee, staff member, right? The same name could apply to multiple things, right? So I need to know both the column name and what relation it is to find out what is the data type associated with that.
For example, if the data type is different, so that's another entry in that.
Mhm.
That's it.
Yeah. So you can have all kind of different,
Like, for example, what I said is that in the name for the instructor is just 20 characters as opposed
Yeah.
to the,
yeah, because the combination of the column name and what relation it is, you define the data type associated with that. So like you said, another one could be 20, another one could be 5. And there's other things that are associated with this that aren't here, but you could have, for example, what is a default value for it, right? Does it have to be filled in, or can it have a null value associated with it, right? So this is a very simplified version of it, but the concept is in your metadata, I have to understand all of the things. I need to know what things are associated with it, and ultimately I also need the order that they're going to appear in. Because once I know where the beginning of the database record is, I need to be able to get all of the data associated with it and return it. Okay, so this is an example of the type of data that you would have in a metadata, but this is a really abbreviated version of it. And to your example earlier, I could say, here's the relation and here is the starting location for it. For example, if I wanted to keep track of where things are. Yeah. Okay. All right, so we have the concept of data abstraction. So what if something is abstract? We have 2 types of abstraction that we deal with. Yes. And those are the characteristics. And what are the types? I love it when you can see the wheels just turning. It's like, oh, I remember this. It's only been 5 months or 4 months since I heard this. It's going to come back to me eventually, right? Okay, so the 2 types of abstraction are data abstraction, which we have here, and procedural abstraction. Right? Okay, and the characteristics that we have associated with abstraction are encapsulation and information hiding. Okay. So in our databases, we are concerned with data abstraction, not procedural abstraction, because we are dealing with data. Wow, see, you guys are really smart, right? Okay, right? So when we talk about abstraction, it's encapsulation. What happens when something is encapsulated? It's combined all together. It's all in one place, right? So when we talk about our abstraction of this, we're saying that for each instance of a student, we're gonna have the name, the student number, the class, and the major, and it's gonna be all combined into one location. We're encapsulating that one unit of data made up of 4 different things as one group. Okay. And information hiding is the concept of, if I go to get it, I may not be able to see everything, but ultimately it's all there. Right? So I may only be able to get it using a key of the student number, for example. Right? So I put constraints on it. Right? So, name exists, class exists, major exists, but the only way to access it is through student number. Right? So you've put a boundary around it, you've grouped it together, encapsulated it. Information hiding, the only way I can get it is provide a student number. Right? So that's kind of an example of what abstraction is about. So abstraction is a data model used to hide storage details and present to users with a conceptual view. So what do I tell you? Go out, and if you give me the student number, I'm going to give you back the name, the student number, the class, and the major, and here's the way that the data is going to be laid out from a size perspective. The name is going to be 30 characters or whatever, right? But here's the data you're going to get back. You have no idea how we went out and got it or anything like that. You just know you put in a request with the student ID number and you get that data back. So that's what we mean by that. Okay. So again, we're referring to the fact that we know from a high level how it works, but how the database management system is doing all that stuff behind the scenes, you really don't know and don't care. Right? Now, somebody had to care because they had to create it, but you probably don't care. Okay, and we have to support multiple views of the data. So each user may see a different view of the data, which can describe what they need. So for example, what don't we like people to see?
Social security number.
Social security number, your address, your birthday, stuff like that, right? So we need to potentially have that, but we're not going to let everybody see that. And if they need to see your address to do their job, they may not need to see your birthday and social security number. So we have another view that lets people see the address and the other stuff, but not, right? So we can have multiple views associated with this to allow different people to look at things in different ways.
Professor,
Yeah.
is it for that particular purpose we create views in SQL?
Yes. But there's actually 2 reasons, right? So views in SQL are to create temporary looks at things. So you can hide data that way. So that is absolutely one of the reasons to do that. The other way is to prevent people from doing bad things. Okay? So Cooper back there typing away, doing stuff. We don't know what he's really doing, right? And if we have a view, he can only look at things. Or if he updates something in the view, it doesn't affect the original database. So it's a data integrity protection as well.
So it's like we have a table which has all the data in it, and we have created different views of it
Mhm.
depending on the users. So that way we have also prevented our data as well as resource.
Yep.
Rather than creating several other tables for each user,
Correct.
we have one master table and different views to access them.
Yes, absolutely.
So there are 2 benefits.
Yeah, absolutely. And so that's exactly why you do it, because how many sources of the data do you want? One.
But then how do you update the view and the master table or the master data?
Right, so for example, right, so the views that we create the view 4 times a day. So at every certain number of hours pass, right, so every 6 hours, we drop the view, so the current view goes away, and we get the updated one, and that is what people see until the next time that we refresh it. And that's good enough for the business. That's why you say, you have to understand what the business needs are so you can create these things correctly. Okay? We have other views that we create once a week. We have ones that we do on the fly because people need them, but they need it as of the point in time that they are to do their job. So we don't automatically create them and sit out there. They log into the system, and the system automatically will create a view at that point in time. But again, the idea is that any updates that are happening are going to typically only apply to the master, right? And then you create a new view and get that brought into the view. Now, there are scenarios that you can create a view and update it there, and it updates it in the master, right? But now you can have a potential integrity problem, right? So in general, even though the system is capable of doing that, most companies will not allow updates to views that update the database. You can update the view, and it will show in the view that it's been updated, and again, it gets back to this kind of batch process, right? I real-time update the views, but then I take all of those updates and I apply them in a batch to the master overnight or something like that. So it always keeps coming back to what is my absolute need to do the job, for you to design it correctly. So, great question.
And to add to that, you took as an example of updating a master table in a batch, like every night. We also would need to update the statistics or like indexes of that master table. So, how often is it recommended to update the master table, the stats of the master table in that case?
Cooper?
It depends.
Yeah, Aquarius.
Yeah, right. So, one of the things that she's talking about is the statistics that she's talking about are ways that the database management system is looking at the data and trying to optimize performance,
Yes.
right? So, ultimately it comes down to how often is the database changing is kind of the major guideline that you typically go by. So if we have some that we have never updated the statistics on a database because it doesn't change often enough, that's going to change the way that data is going to be accessed. And we have other ones that we update the statistics once a week. We have some that we do every night because there's just so many transactions against it, right? So you're looking at how is the database ultimately changing over time is your guide, right? And then on top of that, then you have how is the database really performing, right? Because you could have updates that cause literally no change in performance, and you could do millions of those and not have to redo your statistics, right? So a lot of it depends on deleting and inserting complete sets of data from the table, right? So for us, for example, we update once a week because we don't do any deletes during the week. We only delete once a month. Right? But we do add stuff, so that's going to change things, but it doesn't change things dramatically until we get to about 2 weeks. So we do it every week. So, it depends. That's what I love about doing this stuff, is because I can always have an out. It depends. All right, so sharing of data and multi-user, like we said, we have concurrent users, right? Retrieving and updating from the same database, the same records, right? So we have to have some type of concurrency control, guaranteeing that each transaction is properly applied, right? And if there is a problem, we need to recover, so we have to back it out in the process. So we'll talk about that. Okay, we have the online transaction processing, right? So that's our real-time type of process, right? And again, a lot of this comes down to, are you really changing anything or not? If I'm accessing data, I can have thousands and thousands of users and it's not going to impact things. But if everybody is updating things at the same time, then I can have potential problems. So again, my database design is going to be based on how it's going to ultimately be used in the process, right? So users, right? So we have categories that we can have. So those are actually use and control the database content, and those who design, develop, and maintain it, right? Okay, and we have the ones that are designing and developing the database management software and the related tools. So what they call the actors on the scene and behind the scene. Okay, so on the scene we have database administrators, right? So authorizing access, coordinating, monitoring use, right? Software and hardware resources, monitoring efficiency, right? So that was my job. I also got to be a database designer, so, right? So again, companies separate these out. Sometimes they have them all the same, right? Depends on the company, right? So I was also responsible to define the content, structure, constraints, all that kind of stuff associated with that. Okay. I was also an end user. Wow, so it's like all of these, all the same company. It's really great, right? So I use the data for queries, reports, right? So you have sometimes access, right? So occasionally when you need it, right? Okay, you have people who use it for canned transactions, right? So something that is a repeatable process. So a lot of times you have things like your visualizations that you run a dashboard report, right? We pull data from the database in the background and it does it, but the person has no clue how it happens or what it does, right? So that's what we're talking about here, right? Okay. We've got the sophisticated user, right? So this is your people who actually use the tools to access the data. So it's the person who's going to take a visualization tool and actually develop the dashboard itself. Okay. So I develop it and I am the sophisticated user and I turn it over to Connor to use, or Cooper to use, and he goes off and uses it without knowing how it all works in the background. Okay. So we have those kinds of things. Right. Okay, we have standalone, right? So prepackaged stuff that ready to use, right? So again, we have lots of examples where you go out and purchase software and it uses its own internal stuff in the background to do things, right? So we have that. Okay. Right, we have the analysts and application developers, right? So again, on my team, I have all kind of people that write the structured query language, actual queries into the database. They do the updates, they do the deletes, right? They have to manage all of that stuff, right? So they're the analysts, they're the programmers, they're the business analysts to understand how it all works, right? Build the different models that we ultimately put into the production environment, right? So everybody on my team is able to do practically any one of these jobs. So that's the good news for me. The bad news is to find people to do all of those things is really hard. So I have been really privileged to been able to get together a really strong team that can do all of those things. Okay, so behind the scenes, we have the system designers and implementers, right? So, as we said, your database management system and stuff like that is just software that somebody's created. So somebody had to design it, somebody had to build it, somebody had to test it, somebody has to support it long-term, somebody has to do the maintenance. And what are the 3 types of maintenance again? Wow, that's great. So what kind of, oh man, that was great, right? But the good news is I heard all 3 from various people, so I'm assuming you all are able to give me all 3, right? So we have system designers and implementers, we have the tool developers, and we have the operators and maintenance, right? So again, I'm gonna read through all this stuff, but again, right, you know that ultimately people have to develop the software to do all that work in between. You have the people that build the applications that support it, and you ultimately have the end users out at the end that are going to be on the receiving end of how all of this works. Right? So our advantages for using the database is controlling redundancy in data, right? So again, one of the biggest problems we have just corporate-wide in any company is you have multiple copies of the same data all over the place and managing it. Because if it has to be updated in one place, you have to make sure that you update it everywhere else. And we're really bad at making sure that it is coordinated everywhere. Because it's really easy at the point in time that you build something to know that it's related. 5 years later, when people have all changed around, nobody remembers, you update it in one place, it doesn't get updated someplace, now data's bad. Okay? Your database approach allows us, again, the data, since it's only in one place, I can control access to it better, and obviously the idea of having the integrity of the data. So not only access to the data, but overall integrity of it. And because we have these structures in place, we can look for efficiencies, right? So as we looked in here of creating indexes to allow us faster access, or using the real-time access kind of as a hashing type of function to get me to the location. It doesn't work well for batch, but it works really well for online, so our real time. So again, understanding the way that we want to approach things. Right? So we have optimization of queries, right? So again, our database management systems tend to look at something just like you have optimization for programs, which will just rearrange things so that you have to have less data movement around inside your computer, so it's faster, right? Same thing can happen with our queries, right? So we have some database management systems that will automatically look to say, this query has been executed so many times, it will then tell you that you should create a new index to improve things. Right? So we have self-learning types of database things. Right? Backup and recovery, we'll talk about that quite a bit because that's really important. Multiple interfaces to different types of users, right? Complex relationships among the data, as we said, integrity constraints, right? And inferences and actions from the data based on the business rules that we have, right? Other types of actions is potential for enforcing standards, right? So, well, what's a standard?
Something that everyone should do.
That everyone should do. And we like to enforce standards because if everybody does those, it makes life easier for everybody, as opposed to somebody like Cooper doing things that he shouldn't be doing as outside of these standards, like hanging around corpses or something. All right. Okay, so enforcing standards, we can do that because everybody has to go through the database management system. And it has to go through the gatekeepers of the data administrators or the database administrators. So you have a gatekeeper on that. Okay, it's reduced application development time because, again, you're reusing things that you already have in place. So we do a lot of that. Okay, we have flexibility to change the data structures, right? So as we talked about, we are going to have changes that are potentially going to apply through all the 3 different types of maintenance. So we change things all the time. Okay. Availability of current information, right? So if I have one spot where all the stuff is, guess what? You're always up to date. Okay, economies of scale, right? Again, consolidating things across the different parts of the company. Right? So if we look historically, right, we went from hierarchy and network models, right, to, right, again, IBM's IMS system, information management system, right, is the typical one for hierarchy. And like I said, we try to convert twice systems that we had running in the hierarchy using IMS. And when we converted it to the relational, it was too slow. So we backed it all out. Relational systems started in '70 and emerged really into the mainstream in the '80s and is still probably one of the most popular approaches that we have today. Okay, you have the object-oriented database management systems, right? They are around, but they didn't exceed any of the things that were happening in relational. So what are you going to do if you have something that works? Are you going to change to something that is comparable? No, because it's too much work, right? So they're out there, but really haven't changed much, right? They haven't taken much effect. Okay. So we have the object relational databases. So, right? If you can't make it work one way, what do? You merge it with some other stuff and see if people will adopt it. Right? So again, the idea here is we have some extensions of the way that we do things, but it really hasn't really made significant changes in the way that we do things. Right? So data on the web, right? So again, the use of XML, our scripting languages, the databases in the background for the HTML stuff is just all wonderful, but right? It's all, if we again look at the way that it works, it's all based on things that we've had in the other database management systems, right? It's really just a different view of it, right? So it's like that vendor management versus the cloud. It's the same thing. It's I've got the great new computer that's designed on the architecture from the 1940s and 50s, right? It's just repackaged and so it's all basically the same in that. Okay? So with that, have a great night. We will see you where? Next door, next time. No, it will be covering things, but we are not going into the text. So, I have a list of topics in there because I have to provide it. So we will adjust it by, so this is like all chapter one. So if you read chapter one, that's all the stuff that's. Currently not at all, based on what I have, but I have any requests and have somebody help me do stuff. But I'm not back on it. I will, but so, I will probably, I'm able to have one, well, no, thank you.
注意去签这个立杯子啊！你是有意了，我操！这是我必须要学。是，我也是。但是我到了第二学期学这个。你是到了第二学期。对。你们都是，他会刚来，都是刚来。我是 CRS，Data Science 是 CRS 下面的一个省份。
对啊，那你是什么专业的？
我是 CRS，就是 CRS。CRS 对他们的项目，它总共有3个小方向。All right, see you next week.
All right, hey, thanks for your help.
No problem. I didn't notice you teach this class. You know, I didn't notice you teach this class.
And you were hoping I would.
No, I hope you teach this class because I had a really good time.
Well, that's good because you guys did a really great job, and I appreciate all of the stuff that you did, because it's, in that half semester, it's really tough,
Yeah, it's really.
but in July and August, you appreciated it.
Yeah, just find a job, so kind of busy now as well.
Yeah.
Yeah. Thank you.